We're looking now at section 13.5, which describes measures of dispersion. And measures of dispersion will help us to look at a set and know what the spread of the data is. Measures of central tendency was in 13.4, and that helped us look at the mean, the median, mode, and mid-range. Now we're going to look first at the range, which is one way to look at the spread of data. The range of a set of data can be calculated using the highest value in the data set and subtracting the lowest. So let's say that we have a data set with the following pieces of data: 23, 45, 72, 10, 8, 92, 46, and 87. So from this set of data, if I asked you to find the range, you would first look for the highest value. And because we're looking for a highest and lowest, you wouldn't need to put this in an ascending or descending order. So highest value, let's see, it looks like that would be 92. So we'll take 92 minus the lowest value of the data set, which is 8. And then we know that 92 minus 8 is going to give me 84. This one we aren't given any units, so I'm going to just describe that as 84 units. If this had been milligrams or ages and years, we would include those units in our range. Now, when we have a range, because we're subtracting, taking the highest value minus the lowest value, our range is always either going to be positive, or it's possible if, let's say that we have a set including the following pieces of data: 9, 9, 9, and 9. So if from that set I took the highest value and subtracted the lowest, I would end up with a range of 0. So it is possible, if every piece of data or every observed value in your data set is the same, that we would have a range of 0. If we have a highest value minus a lowest value, we'd end up with a positive range. So the range will never be negative. It'll always either be positive or 0. So we've talked about range. Now let's look at another measure of dispersion. This one is standard deviation. And what's nice about standard deviation is it describes how much the data differ from the mean. So let's look at this set. This is an easy one to explain since all of the data pieces are the same. We know that even just looking at it, that when I figure the mean, I would get 9. Now we know mean is we add every piece of data divided by the number of data. So 1, 2, 3, 4, 5. So when we add those, divide by 5, we would end up with a mean of 9. Now as I look at every other piece of data, there is no difference between the mean and each of those pieces of data. So I would have a standard deviation that was equal to 0. However, as my data started to differ more and more, the larger your standard deviation would be. So let's look at that formula, and then we'll go through. I'm going to show you how to use this formula using a chart, and I'm also going to show you how to verify on your calculator, which will be very helpful to you as well. But you do need to memorize this formula. Here we have the standard deviation, and we're going to use an S of a set of data. Can be calculated using the square root of the sigma says the sum, and I'll show you how to do that as we keep going forward in our example. The sum of each data piece minus the mean squared is in the numerator. We'll divide that by the number of pieces of data minus 1. Okay? And to help us a little bit further with that formula, in your textbook, or also listed here, we've got a list of steps in calculating it. So we have determine the mean of the set of data, making a chart that has 3 different columns: data, data minus mean, and data minus mean squared. And then once you do that, we'll be able to fill in that formula appropriately. So let's look at a set of data. Let's look at the data set 8, 15, 24, 37, and 16. So first we want to determine the mean of the set of data. So to determine the mean, we would add 8 plus 15 plus 24 plus 37 plus 16, and then we want to divide that by the 5 pieces of data, which gives me a mean of 20. So the mean is equal to 20. Next, we want to make a chart with the following columns. We want, first of all, the data. So those will be our x's. We want the data minus the mean. So the x's minus x bar. And data minus mean squared. Okay, so let's list our data first. It does not have to be in descending or ascending order, since it's just a list. 8, 15, 24, 37, and 16. The data minus the mean, so each piece of data will subtract the mean, which would be 8 minus 20, so negative 12. 15 minus 20, negative 5. 24 minus 20 would be 4. 37 minus 20, 17. And then 16 minus 20 is negative 4. And what's nice here, this serves as a good place to check your work if you have calculated the correct mean. At this point, if we add this data minus mean column, so we'll take negative 12 minus 5, so negative 17 plus 4 is negative 13, plus 17 is positive 4, minus 4 is 0. And if you've done this part correctly, you should end up with the sum of 0. Okay, the next column, we take the result from the second column and we're going to square each one of those. So x minus x bar is what we calculated already. Let's square each one. This one would be negative 12 squared is 144. This column will produce only positive numbers since we're squaring each piece. Negative 5 squared is 25. 4 squared is 16. 17 squared is 289. And negative 4 squared is going to give you a positive 16. And then we do want to calculate, because in our formula, let's go back to that standard deviation formula. The standard deviation formula was we're going to take the square root of the sum of x minus x bar squared all over n minus 1. Well, what we've just found in this column, this was our x minus x bar squared. When we sum those, so let's add those values together, we would have 144 plus 25 plus 16 plus 289 plus 16, which gives me 490. So the sum here would be 490. That is this part of your formula, the sum of x minus x bar squared. Okay, so far we have the square root of 490 divided by n is the number of pieces in your data set, which was 5, minus 1 gives me 4. And then in my calculator, we can do this all at once. Let's do that. We'll take the square root of, I'm going to open up my parenthesis because I will have a fraction here, 490 divided by 4, close the parenthesis, press enter, and I end up with 11.06 We're going to round this to 1 decimal place. You'll be instructed in your homework how many decimal places to use, but since our data set included integer values, let's at least go 1 decimal place out, which would be 11.1, and that's your standard deviation for that data set. Now if I want to check that in my calculator, let's go to the calculator. There's a nice video within Blackboard that'll show you how to use your calculator in descriptive statistics. So we're actually going to do exactly what that video instructed, which we're going to have, if you go in your calculator to the data screen, so this data button gives you a table, and we're going to provide a list under L1. Our lists are going to be the pieces of data that we've just calculated. So 8, and you can use your arrow key or enter, 15, 24, 37, 16. Okay, and that's our complete list. Now under that same button, if I use the second function, you see stat, second, stat. We're using only one variable, statistics, so press enter. And then we're telling the calculator which list to use, and we've only provided a list under list 1. The frequency, the way that we've shown that list is every piece of data is only in the data set once. So we're going to go even down one more to calculate, press enter. And then you're provided with a long, nice list of some interesting figures that the calculator has gathered from your list. First of all, number of pieces of data was 5. Our mean we already calculated and said was 20. Here's our standard deviation of 11.1 approximately. And then now what we used was a sample standard deviation. This second one is another kind of standard deviation that uses a population instead. We'll be using this that's S sub x there. And then there's some other things, the sum of all the x's, some things that we don't cover in this course, but if you keep on scrolling down, you'll see quartile 1. MED is the median. Also quartile 3, we know that the median is also the same as quartile 2. The maximum x is your largest x value. And just a really nice comprehensive list of some different statistics that might come in handy. So that should give you a nice way and a nice example to go through and find standard deviation, given a list of data, setting up a table using the formula, and then checking your work using the calculator. You will be on your test, you will be instructed to show your work using the formula and using a table, but of course it's nice to be able to check your work and know that your answer is correct, and you can certainly do that using the TI-30XS calculator.